Hello, welcome to Unit 13 on probability. This video is going to encompass all of day 1, which is the difference between categorical and quantitative data, probabilities versus frequencies, and something you guys may be familiar with from Algebra 1, which is two-way tables, which is a way for us to organize data. All right, so bringing it on back to middle school when you guys talked about probability. The probability is always between 0 and 1. So a probability can be expressed as a fraction, a decimal, or a percent. Like there's a 70% chance of rain, for example. That's a probability. If the probability of an event happening is 0, that means it won't happen. If the probability of an event is 1, it means it is certain to happen. So the probability would be 1 for an event, like there's a 100% chance that it's going to snow today in Buffalo. Goodness, I hope not, being later May in our class. But if it's the probability is 1, that's a 100% chance. It's certain to happen. If it's 0, then it won't happen. All right, so first of all, differences between types of data. We got categorical, or sometimes you'll see it called qualitative data. This is data that has names or can be put into categories. So for example, the color of a ball, red, green, blue, breed of a dog, so collie, shepherd, lab, terrier, whatever. These are things that fit nicely into boxes. It's a success versus failure thing. Your dog is either a collie or it's a terrier. The ball is either red or is green. What category does it fit into? So other examples we could have are grade level. So that student is a freshman, they fit in the freshman category. That student is a sophomore. So you could say something like I have 25 sophomores and 20 freshmen in a class, etc. You could have what type of pets people have. I personally remember being in elementary school coming up with bar graphs on who had a cat and who had a dog and maybe who had something different. So that's categorical. And then lastly, maybe something like hair color or eye color, etc. Now, quantitative data is data that can be expressed numerically. So for example, we could have the number of students in a class, the heights of all of our 9th graders, and the averages of graduating seniors. Those are things that are all described numerically. So another example could be, we could have age. You could have like the average age of a group. You could have number of cats in household, because why not? Maybe it's the circumference of a tree. All right, trees plural, because maybe that's something you're studying, the circumference of trees in a backyard, something like that. These are things that are all described numerically. Okay, so take a second, pause the video, and see if you can determine which of the following is categorical. So fits nicely into a category. Ready, set, and go. And these are the answers. So one that sometimes gets people is number 7, outcomes when tossing a fair coin. It's success versus failure. This is where we're looking at heads versus tails for the outcome. So the coin was either a head or it was a tail. Okay, so we're going to come on down to our first two-way table. So this is a way that we organize data that is categorical. Everything's nicely fitting into a certain box, into a certain category. So we have males and females. So we're looking at gender versus type of car that they own. So we have an SUV versus a sports car. When it asks how many people were surveyed, that's this number right here. That's 240. That's our total. So it's in the lower right. Again, this is categorical data because everybody is fitting nicely into a box. Yes, numbers are involved, but it's not like we're describing them with a unit of measure. We have 21 males who own an SUV. That fits nicely into a category. So how many males drive sports cars? So I'm going to go to males, sports cars, and that answer would be 39. How many people drive SUVs? So I go to SUVs, and I go to the total, because I'm counting both males and females here, and that would be 156. What percent of people surveyed drive SUVs? So when it says what percent of people surveyed, that's of the 240 people we asked, so our total number, how many drive SUVs? Well, we just found that 156 of them drive SUVs. So if I go to my calculator and I do 156 divided by 240, I get 0.65, which as a percent is 65%. So 65% of our total here drive SUVs. What is the frequency of those surveyed that prefer a sports car? When I ask you for a frequency, that's just a number. That's another way of me saying how many. So of everybody who's surveyed, who prefers a sports car or owns a sports car? So I got sports car right here. The total number is 84, and that would be our answer. What percent of those surveyed were female? So again, out of everybody, the total number of females is 180. So I would do 180 divided by 240, which will do the math for us, is 0.75. That means 75% of our study was female. All right, lastly, how many people in the study are males or drive an SUV? Okay, so let's actually break this down. How many people are males? So if I go here again, I'm going to erase this a little bit. Males, 60. I'm seeing 60 people in our study are males. How many drive an SUV? Okay, so here is SUV again. That's 156. Now here's the thing. With or, you need to consider that you have males who drive an SUV. So there's an and in there. So these are the males. These are the people who drive SUVs, but keep in mind, that's males and females. You're counting males twice technically. Once here and once there. So what I gotta do is now figure out, well, who does both? Okay, because you can't count the same people twice. So if I look at my table, males and SUV, there are 21 people that fit into both of those categories. So 21 people were counted here as well as there. So if you're counting them twice, well, then just subtract away one of them. So we're going to take away the overlap. Okay, so I do 60 plus 156 minus 21, and I get 195. So that is how many people, or how many males, or sorry, that is how many people in the study are males or drive an SUV. So that's, they're males, they drive an SUV, and we just got to take away the people that do both. Now, sometimes I have students think about it a little bit differently as well. They'll say, okay, well, these people are driving SUVs, these people are driving SUVs, and these people are also males over here, but they drive a sports car. If you actually sum 135, 21, and 39, that will give you 195. But the reason I'm doing it this way, is because we're going to refer to this method a lot, and this is called our OR formula, where it's each of them separately and then taking away the overlap. So this will have a recurring theme throughout this unit. Okay, next page, different example. A town is considering building a new turf field and wants to poll the town members for their opinions. The table below shows the responses from the ages of 18, or people ages 18 and up. The responses have been organized by age category. Okay, so this is categorical because even though we're talking about ages, we're putting people nicely into boxes, into categories. You fit in the category of 18 to 25, or you fit in the category of 26 to 40. So yes in favor, no in favor, or no answer, so maybe no opinion. Now, something you need to know about a two-way table is that you're going to need the totals. So all you have to do is sum up the numbers vertically here to fill out the totals in the margins. So this would sum to 273. Sum these numbers together, that'll give you 230. These all sum together to 12. And then I'll do the same thing, but now horizontally. So 61 plus 14 plus 0 gives me 75. Then 203. Then 149. Then 88. Okay, so then from there, our total, if you did everything right, these numbers should be the same as these numbers summed together. So here, let me pull out my calculator. Make this a little smaller. Okay, so I'm going to do 75 plus 203 plus 149 plus 88, and that gives me 515. Now, if I add the numbers along the bottom here, I should get the same answer. So 273 plus 230 plus 12. And I get the same answer. So the grand total of people that we surveyed was 515. So now we're going to talk about different types of probabilities you can draw from these two-way tables. The first is called a joint probability. This is where you use a single cell count, like 61 for example, divided by the grand total of 515. So 61, 515. Okay? So what percentage, rounded to the nearest tenth of percent, of those surveyed were 41 to 65 years old and said no? Okay. So we're looking for, out of everybody surveyed, who was 41 to 65, and they said no. Okay, so I'm going to go to my table, and we go 41 to 65, and they said no. That's 79. So of everybody who was surveyed, so out of the 515, it's 79 out of 515. Now the problem asks us to round to the nearest tenth of a percent, so if I divide this, pull up my calculator, 79 divided by 515, I get 0.153, we'll say. Dot, dot, dot. Oh, actually, you know what, I should have included another number. Oh, it's another 3. So then, if I multiply by that by 100, I would get 15.3%. And that's our joint probability. Marginal probability means the answer is coming from the margins. So it's a subtotal divided by a grand total. So for example, what is the probability of being 41 to 65 years old just in our study alone? So nothing about the preferences or anything, just, hey, how many or what probability of people fall in this age bracket? So I go ahead, I go to 41 to 65. At the very end, there's our number, 149. So 149 out of our grand total of 515 is the number of people in that age bracket in our study. Now you'll notice I'm not dividing that or anything because it just said what is the probability. I'll just leave it as a fraction. That's a probability. Because remember I said probabilities could be fractions, decimals, or percents. The reason I changed it up here is because it specifically asks for nearest tenth of a percent. So just make sure you're reading. Lastly, conditional probabilities. This is calculated using a single row or column and ignoring every other outcome in the first variable. Conditional frequencies rely on a row or column, not the total. So essentially what we're going to do is divide a single cell by, instead of the grand total, the subtotal. So for example, let's say we want the probability. So what is the probability of being 26 to 40 years old. Now here's what gets important. Given that you said no. Okay? So this is the part that you're paying attention to. That's your denominator. So given you said no. Let's come back up here. Clear out some of these. Given you said no, that's 230 people. Given you said no, who was 26 to 40? 84 of them. So you're ignoring the yes column, you're ignoring the no answer column, you're just solely looking at the given you said no. So of you 230 people, 84 of you were 26 to 40 years old. Okay, so I go ahead and I fill this in. So 84 out of 230. Again, it's just saying what's a probability, so I'm just going to leave that as our fraction. Okay. Last page in our notes here. Students were surveyed and asked what their favorite subjects are. Results are shown in the table below. So what you need to make sure you guys are paying attention to is that you're going to have to complete this table. So take a second, see if you can fill in all the numbers, add up what you can. Like for example, I know 9 plus 4 plus 7 will give me 20. 20 plus 20 is 40, and so on. So see if you can fill in the rest of this table. So go ahead and pause. Okay, and those are the answers we should have had. So we completed the table. What percent of students surveyed are girls who prefer English? So girls who prefer English. So girls, English, 4. So it's saying what percent of the students surveyed. So that's of everybody. So I got 4 out of our 40 total students, which means that's 10%. What percent of surveyed students prefer math? Oh, actually, you know what? I forgot to answer the last question. It says, is this joint, marginal, or conditional? Well, since we're doing a single number, a single cell here, divided by the grand total, this is a joint probability. Okay, next one. What percent of students surveyed prefer math? Okay, so here's math. I see 16 people prefer math. So 16 divided by our total of 40. Now, since this number came from the margin, that's a total, that's a subtotal, divided by the grand total, this would be marginal. So sorry, 16 divided by 40 would be 40% if you divided them multiplied by 100. What percent of students prefer a subject other than math and English, given that the student is a girl? Okay, that's really important. So given the student is a girl, okay, we have 20 of those. What percent of the students prefer a subject other? I'm seeing 7 of those. So 7 divided by 20, again, convert to a percent. You can check me on this, would be 35%. Now, since we're only looking at part of the table, not the whole table, and we got that keyword of given there to tell us that, that means this is a conditional probability. What is the frequency of boys that prefer math? Okay, so boys preferring math would be 7 of them. A lot of people like to write 7 out of 40 there. Careful, it's not asking for probability, it's just saying, hey, how many? So that's where it's just a number. Okay, how many do you have? There's 7 boys that prefer math. Last question in this section, what percent of boys in the study prefer English? Okay, so this is where the wording is a little bit tricky. What percent of boys? So either it's a given or an of, you look for that key language. So of the boys, which there are 20 of them, I can see that 3 of them, oopsies, sorry, not 3 of them, we're talking about preferring English. I can see that 10 of them prefer English. So again, what percent of boys, as opposed to what percent of students. So that's where the wording's a little bit different. You'll see up here it says what percent of surveyed students. Now it's saying of boys. Of these 20 boys, 10 of them prefer English. So that would be 50%. And again, since we're only looking at part of the table, we're dividing by the subtotal. This is a conditional probability. Okay, moving on to our last section here, our last question. You'll notice I'm not giving you a two-way table. We're actually going to draw one based on the information given. Okay, so it says, in a survey of 400 teenage shoppers, 240 said they shopped at Under Armour, 210 said they shopped at Nike, and 90 said they shopped at both stores. Okay, so we got two things that we're really looking at here. We're looking at shopping at Nike versus shopping at Under Armour. So what we're going to do is draw our two-way table. We've got Under Armour, so I'll just write this as UA, and then I'll just write not UA. So that means you're not shopping at Under Armour. Then we've got Nike versus not Nike. So you do not shop at Nike. Now in the margins, keep in mind, these are your totals. Now, based on what I know from reading this, I got 400 teenage shoppers. That's the total. And then 240 of them said they shopped at Under Armour. So Under Armour total, 240. 210 said they shopped at Nike. And 90 said they shopped at both stores. So this is where they overlap, Under Armour and Nike. Okay, so you can see I filled in some information. Now it's your job to fill in the rest of the table. So I'd say pause the video and see if you can finish that table. And there you go. So how many teenage shoppers did not shop at either? Well, not Under Armour, not Nike. That's 40. So 40 students did not shop at either store. What percent of the Nike shoppers? So here's where it gets specific. Of our Nike shoppers, I can see 210 of them. That's over here. What percent of Nike shoppers also shop at Under Armour? So remember, there's those 90. So this is 90 out of the 210, which it says to the nearest tenth of a percent. So I'm going to go ahead. I'll do 90 divided by 210. Multiply by 100. So to the nearest tenth of a percent, it looks like 42.9. Okay, not that it asks it there, but based on this wording, guys, this is actually a conditional probability. Because again, you were not relating it back to the grand total of 400. You were relating it to the subtotal of 210, which was those who were Nike shoppers. So the key words that you look for when you're doing conditional probabilities, look for the word given, and look for the word of. So of the Nike shoppers, given the person's Nike shoppers, things like that. Okay, and that concludes our notes on day 1. Hopefully this sounds familiar from what you guys learned in Algebra 1.